So in this next chapter, we're going to be looking at everything to do with triangles. So we're going to learn new rules, so the cosine rule, the sine rule, and finding the area of a triangle. And therefore, we can find everything to do with this triangle, such as like the length or like an angle in between two sides. And so it's all dependent upon what rule we use. So the first rule we're going to be using is the cosine rule. So I'm just going to write out what the cosine rule is. It's going to be a squared is equal to b squared plus c squared minus 2bc cos a. A. Right, so if I was to draw a triangle like this, the lowercase a, so the lowercase letters represents the sides of the triangle. So A, B, C. Doesn't matter which one you label as A, B, C. And the capital A represents the angle opposite the side. So in this case, this is A, right? So this here will be the angle opposite the side A. So therefore, this angle will be capital C, and this angle will be capital B. And so the cosine rule is used when we know two sides and angle in between. Okay, so if we know two sides with an angle between, then we can use the cosine rule to find the final length. Okay, so if we know two angles or two sides with an angle in between, we can find the third length of that triangle. So this is when we use this cosine rule. So let's try an example. So let's look at this one here. As you can see, we have two sides and we have an angle in between, so we can use the cosine rule. So it doesn't matter, they've labeled it ABC as their own. It doesn't matter which one you choose as ABC, but just be consistent with it, okay? So in this case, if I was just to rearrange it, then this would be A, this would be B, this is C. It doesn't really matter if you change it around. So in this case, you don't want to change it around, but just for yourself, you can change it around. So it will be, let's call this A. So A squared is equal to 10 squared plus 10 squared minus 2 times 10 times 10 cos 40 degrees. And it's just a matter of plugging it into a calculator and finding what A is going to be. So A will be roughly 6.84 centimeters. Okay, so as long as you identify which one is your ABC and your correct angles relative to these lengths, then you just have to plug it into the calculator. Right, so that's how you find a length if we know two sides and an angle. But we might also know all three angles, or all three lengths, sorry, and we might want to find an angle. So initially we have the a squared is b squared plus c squared minus 2bc cos a. I'm now going to rearrange for cos a, okay? So moving around, so I have 2bc cos a is equal to b squared plus c squared minus a squared. So therefore, cos A is equal to b squared plus c squared minus a squared over 2bc. So it's just a rearrangement or just manipulating the initial cosine rule formula, but this one is used when we know all three lengths, okay, and we want to find an angle. Okay, so if we know all three lengths and we want to find, and we have no angles known, then we can use this form of the cosine rule to find that angle. So let's try it with this one here, okay? So in this case, we have three lengths which we know, and we're trying to find the angle. So as we said, it's cos, I'm going to leave as ABC, these vertices ABC, right? But now I'm going to just rearrange it. So initially it was cos A is equal to b squared plus c squared minus a squared over 2bc, right? You can just do it in this form as well, right? So in this case, AC, so cos C is equal to, this length here will be C, this would be B, this would be A, so it will be a squared plus b squared minus c squared over 2ab. So it's just writing it in different forms because the lengths or the labeling is all different for each question, right? But the concept still stands. So in this case, a squared is 7 squared plus 24 squared minus 25 squared over 2 times 7 times 24, sorry. And if you work this out into the calculator, you find that C is actually 90 degrees, which means that this is actually a right angle triangle. Let's just try one more here. So we have triangle ABC. AB is 9.3. So AB is 9.3. BC is 6.2. And AC is 12.7. So to calculate the size of the largest angle. So for triangle rules, right, the largest angle is always opposite the largest length. So this here will be the angle we're trying to find. Let's call it x. Once again, it's just using the cosine rule. So it'll be cos x will be equal to the lengths either side, so 9.3 squared plus 6.2 squared minus 12.7 squared over 2 times 9.3 times 6.2, which you can plug into the calculator again, okay? And so therefore, and you get your answer as 18.4 degrees. But working at the final answer is not important. The important part is understanding which part is your A, B, C, and which lengths are which angles are your capital A, B, C's, and making sure you apply this correct formula form. Let's just maybe try one more. Okay, so we have the diagram which shows 3 cargo ships A, B, C, which are in the same horizontal plane. Ship B is 50 kilometers due north of ship A, so let's just draw it out. This is ship A, and B is here, where it's 50 kilometers, 50 km. And ship C is 70 kilometers from ship A, so roughly here, at a bearing of 0 to 0. So remember, bearings are always relative to the north side. So 0 to 0 would be an angle of 20 degrees like here. Okay, so bearings is always clockwise relative to the north. So this is going to be 20 degrees, and this is going to be C, and the length is 70 kilometers. And they're asking us calculate the distance between B and C, like this one. Right, so it's, as you can see, it's a triangle shape, so we can use a cosine rule because we know 2 lengths here, and in between are the angle in between, which is 20 degrees. So we can just use a cosine rule, so BC squared is equal to 50 squared plus 70 squared minus 2 times 50 times 70 cos 20 degrees. And if you put that in the calculator, you get BC as 28.7 kilometers. B, calculate the bearing of ship C from ship B. So once again, it's a bearing, so it's relative to the north side, okay? So the angle we're trying to find is this angle here. Let's call this angle X, because that's the angle we're trying to find. So in order to do that, we're actually going to need to find this angle here, right? Because this line is 180 degrees, so I can do 180 minus this angle, let's call it Y, to get my X value. So once again, because we know BC is 28.7, we know all 3 lengths, right? 1, 2, 3. So we just use the cosine rule where we find the angle formation. So it'll be cos Y is equal to the ones either side, so 28.7 squared plus 50 squared minus 70 squared over 2 times 50 times 28.7. And if you work this out, your Y value will be 123.3 degrees. So therefore, to find X is just 180 minus 123.3, which will give us 56.7 degrees. But it's a bearing, right? So bearings are always have to be integers. You always should round up, and they always have to be 3 digits. So yeah, the bearing would be 0.57 degrees. That's the bearing. Okay. So as you can see, just as I identify where my lengths are, what the appropriate angles are, and as long as you use the right form, then we get all the right answers. Okay. But this might take a bit of time getting used to, right? Because you might just some of you the common mistakes students make is choosing the wrong lengths as the wrong angles, or plugging in into the wrong form. So just be aware of this mistake and just keep practicing this kind of question. And once after you practice a lot of these, then you should really have no problems with these kinds of questions.